So let's talk normal distribution. So discrete probability distribution looks like this. This is what we've been doing so far. We're talking about just when it's a 2 showing as a sum, or just when it's 3, or just when it's 4. Today we're going to be talking about values that continuously grow and fall. Okay? See how this one's smooth, this one's rigid? Discrete, continuous. Okay, I will be able to solve problems involving normally distributed data. I'll be able to explain whether a set of data appears to be normally distributed or skewed, is what we're going to do today. These are your normal distributions. This is your big idea. Okay, so this is called a bell curve. All right, shaped like a bell. Because this type of statistics and seeing things like this is like something you'd see when you'd open a newspaper. And today I'm going to explain it to you so you'll know what it means.
Is that the title of the
Yes. So oftentimes that's what's bad about statistics is people can take images and make it look like what they want it to look like, right? Unless you're knowledgeable and understand the math behind it, then you can, make your own assumptions based on what you see, the data that's in front of you. Okay, that's why it's really important to know this stuff. All right, so in a normal distribution, right here, let me change my pen. Let's make it red. So right here would be your mean. What does the mean stand for? The average. Your median, what's the median stand for? Your middle. And your most? Your most. So isn't it interesting that in a normal distribution, all 3 of those measures of central tendency are all right here? And this is called X-bar. That's what stands for mean. Okay, so sometimes when we have data, this continuous data, sometimes your data gets skewed. So if it's skewed going off into the positive direction, if it tapers off to the right, then it's a positively skewed graph. If it tapers off to the left or tapers off into the negative direction, it's negatively skewed. So make sure you have a rough sketch of all 3 of those, please. Okay, so let's look at classifying data. Determine whether the data set, that's right here, that's what this means, the set, appear to be positively skewed, negatively skewed, or normally distributed. So what you do is just organize the data. So make a frequency table. I spelled that wrong. All right. So it starts with 31, so I'm going to say my value, and then how frequently I have it. I'll give you time to write, so don't worry. How frequent it occurs. So how many times do I see 31? There's 1. That's it, just 1. And 32? 1, 2. And 33? Only 1. And 34? 1, 2, 3, 4. And 35? 1, 2. And 36? 1, 2, 3. And 37? 1. Okay, so if I were going to make a table, use the table to make a histogram. So 31, 32, 33, bless you, 34, 35, 36, 37, but this isn't the tedious part. 1, 2, 3, 4. I'm just making a rough sketch. So there's 31, there's 32, there's 30, oops, too big. And 34 goes all the way up. And 35 just goes up 2. And 36 goes up 3. And 37 goes up 1. So, would you say that's positively skewed, negatively skewed, or normally distributed? I would say normally distributed as well. This one's up high, these are down low. These are kind of in the middle, these are down low. It's pretty normally distributed, right? We're going to look at that in a second. Normally distributed. Okay, go ahead and write that down. 1. Okay, so why don't you go ahead and put this in your clicker. Give me a second. It's starting, it's starting. All right, put your answers in. It's set up. No, just for general ed.
I have a debate on economics. High frequency trading does more good than harm.
All right, let's see how you guys did. Ooh, we're pretty split. Quite the argument. Okay, so this one, see how it's higher, like this, and see this side? It goes kind of lower. It looks like the negatively skewed graph, right? Okay, let's move on. All right, I need your attention again. So this is called a normal distribution. Okay? Where we have, just as I said, change this up again, make it look pretty. See? You're going to put more on it this time. Where the mean, the median, bless you, and mode are about equal. And I know I already said that, but we're going to put more on this. The maximum is always the mean. All right, now I'm going to change my color. So in every normal distribution, and wait, here's our X bar, our mean, 68% of data will be one standard deviation. So 68% are within one standard deviation. What is standard deviation? Standard deviation measures how far data can differ from the mean. And I'm going to give you a real-life scenario in a minute, and once I do that, you guys will be... Well, no, it'll make a lot of sense to you. And I can give you any example over and over again in the book, but the one I'm going to give you next will hit home for everybody, and you'll be like, oh, I totally get it. Okay? I don't know why the book doesn't give this certain example. It doesn't make any sense to me. No, it's just not very practical sometimes.
Is it
Yes.
50% for everything?
All that it means, let's just write this down. And the next example, I won't even have to answer any of your questions. You're just going to get it. Okay? I can. I guarantee it. It's a guarantee. Okay. So here, all of these data points are, that's 95%, are within 2 standard deviations. We should have written one more thing. So, if this is 68%, how much is in this little bar right here? 34. And in this bar here? 34. So, if this is 68 and all of it is 95, can somebody tell me how much would be in here? No. 13.5. You didn't cut it in half, right, Kevin? But that was quick. 13.5. We kind of call these the tails out here. Actually, I'll just make it pink. I'll make my own tails. So there's a tail here. How about right here? There's one here, and then there's another one here. 2 more tails. Or I should say this is the tail and 2 more little intervals. Okay, so there's not really enough room, but what if I were to tell you that there was 2% of data in here and 2% here? That makes it 99. So how much do you think is in this small little area over here? 0.5 exactly. Which would total 100%, right? Okay, so once you have that down, then let's make meaning of it. All right, so what about IQ? Does anybody know the average IQ? It's 100. Yes, the average IQ is 100. One standard deviation for IQ is 15 points. One standard deviation is 15 points. So if I were to add 15 points, what would be one standard deviation away? 115. And if I were to go in the opposite direction, somebody that's not as smart as the average person, how much would that be? 85. So this is saying that 68% of the population have an IQ from 85 to 115. Now, is it making sense?
Everybody in the world?
No, 68%. Yes, of the entire population. Yes, have an IQ between 85 and 115. Yes, sir. Okay, so that's what you're going to learn on Friday. So what they do is they take everybody in this room, right? They take a huge population of people, and they take your IQ, and they subtract it from 100, and they square it. And they take yours, and they subtract it from 100 and square it. And yours and subtract it from 100 and square it. Everybody's and subtract it from 100 and square it. And then they take the average and the square root, and they come up with 15. So within one, and isn't that interesting how that happens? So if something is normally distributed, it will always, 68% of data will always be within one standard deviation. Okay, so you see why I didn't want to teach you how to find standard deviation without telling you what standard deviation is? Yes, sir. No.
Everyone.
Just everyone.
No one is excluded.
Okay, so if I were to go up one more standard deviation, what would this be? 130. 130. Oops. Sorry. Well, just wait. Evan, you are not learning when you're just automatically asking question after. Just let things sink in, and more importantly, other people need a chance to let things sink in. Okay. Hold on one second. So 95% of the population is between 70 and 130. I believe once you're classified as mentally disabled is around 60. Is 70 the cutoff?
Yeah, because I was having a discussion about it. So like,
Did you?
69, and technically the target, but then again, they don't come out, they're not.
And that's a discussion to have, right? I did think it was higher than 60, but somebody in the last class said 60, and I didn't look it up. So it is 70. That would make sense why it would be at the cutoff of 2 standard deviations, right? Because that means, go ahead, that means that if 95% of people are in this range, if you're 69, you're probably not, having some issues, right?
Yeah.
Yeah. Okay. Yes, sir.
How many standard deviations are there?
There. Well, let's finish. Okay. So what would be the next standard deviation?
145.
145. And this would be what? 55. And how much would that be? It will always be the same. That's 99%. Okay? So if you had a IQ of over 145, what percent of population would that be? 25% have an IQ of above 145. No, my son's not a nerd. He's right here. Yep. I was going to get him a shirt that said, "I'm right here." Yeah, so what would be the highest you could possibly score? No, 145 would be 160, right? And what's the lowest you could score? 40? And how many standard deviations is that? If this is 1 standard deviation, right? No! What's the excuse this time? If this is 1 standard deviation, this is 2, right? This is 3, then how far can we go, Kevin? 4. 4 is the max, right? So 100% of your population will be within 4 standard deviations. Okay? Did that kind of explain it?
Yeah.
Okay. It's the way that they calculate how far away you are from the mean. The percentage, what? Okay. All right, so let's use this. Students counted the number of candies in 100 small packages. They found that the number of candies per package was normally distributed, with a mean of 23 candies per package. So I put my mean right in the middle, 23, and a standard deviation of 1 piece of candy. So if 1 standard deviation away is 1 piece of candy, what would be here? 24, 25, what about here? And how many packages had between 22 and 24 candies? 22. How many packages had between 22 and 24? 68%, but it didn't ask me the percentage, it asked me how many. So 68% of 100 packages is 68. Okay. You guys want to write that down? You don't have to write it all down. You could just say, I don't know exactly what you want to write, but you don't have to write all that down. It's pretty self-explanatory, right? So what is the probability that a package selected at random had more than 25 candies? Here's 25%, or here's 25. What percent has more than 25? 2.5. Right? It's basically just reading and understanding graphs. That's it. That's it. That's the answer. 2.5% would have more than 25 candies, right? If it's evenly distributed? Yep. Okay. Why don't you guys put this one in your clicker? Let's see how you guys did. Look. Okay, so it says the students counted the number of candies in 100 small packages. They found that the number of candies... Please stop talking. Why are you talking over me? It said that the mean is 23 candies and a standard deviation of 1. This is 24 and 25, and this is 22 and 21. About how many packages had between 25 and 21? So between 25 and 21 is not 5 packages, right? It would be 95 packages. Okay? All right. What is the probability that a package selected at random had more than 24 candies? Let's see if you can all get this one. Well, what was the mean? Whoa, that is not good. That's not good at all. Guys, I thought we were at least within 2 standard deviations of the mean in our IQ. I thought. All right, guys. What's your mean? 23. So this would be 24 and 22. Thank you. What percentage is that? So why did you guys have such a hard time on that one? How do I know? Because if this is 68, guys, I have a question. 5, 4, 3, 2, 1. If this is 68, how much percentage is right here? How much is this? 13.5. And how much is this percentage here? 2. And how much percentage is this one here? 0.5. Add them all together? 16. I can't believe we landed on that note. Seriously. Okay, we passed these back. All right. 5, 4, 3, 2, 1. Okay, quiet down. What did you learn today? Normal distribution. Okay, guys, freeze, please. Thank you. Positively skewed data tapers off to the papers off to the
yeah, that way.
right.
That way.
Yeah.
That way.
Oh, you can and negatively skewed data tapers off to the on your assignment sheet, in your own words, explain the meaning of standard deviation. Hold on, let me get so everybody has their blue paper back. Yes, everybody. Then you can just sit there because you didn't do your homework and get punished.
Oh, no.
I don't care.
I don't care.
I care. That's Okay, have a good day.